In this video, I'm going to go over the dial calipers, how to use them, and what they are. So dial calipers are arguably the most common and versatile of all the precision measuring tools used by engineers and manufacturers. There are 4 measurement types on this. There is the outside diameter or object thickness. Between here and here is how you would measure that. The inside diameter, space, or width. Like if you have a hole in something, you would use this part of the dial caliper. And a step distance, which is from here to here. On the back there is like another, actually it's like right along here, which I'll show you in a little bit. And the hole depth, which is whenever you use this section here. Okay, so a standard inch dial caliper will measure slightly more than 6 inches. The measurement made between the caliper faces shown. This was the outside measurement. An example is outside diameter or object thickness. That's where you'll probably use that function the most. Okay, just like this. On the inside, that's like if you have a hole or a slot width. Right here, from here to here is the same distance as from here to here, which is the same distance from here to here, which is also the same distance from here to here. So this one though, if you're using the inside distance, you'd use probably to, like it says, a slot width or a hole. That's an example of it being used. All right, and here is your stepped length from this distance to this distance. Again, that's the same thing as from here to here, as well as from here to here. So, but this one's called the stepped length, and you'd measure something kind of like that with it. Right, and the last part is the hole or recess. It's a little, see how it's really thin? It's basically the same concept as the stepped, but it's a little bit smaller, so it'll go into a smaller space. An example here. Okay, the blade is the immovable portion. The slider is this part. The blade scale divides each inch into 10 increments. Each increment then equals 1/10 of an inch. So if you haven't already, you might want to grab a dial caliper so that you can kind of play with this while you're watching the video to kind of see what I'm talking about. And also for the practice video, you're going to want one as well. So you may want to pause it and go get one right now if you don't have one at your desk. So the pointer rotates within the dial as the slide moves back and forth along the blade. So if you'll move your dial caliper one rotation, okay, so right off, whenever you sit down with your dial caliper, make sure it's on 0, and I'll show you exactly how to do that in the video. But you make sure it's on 0, and move the slide one rotation. And you'll see that it's going to go from either like 1 to 2 or wherever you happen to have it set. So this one would go from like 7 to 8 if it moved one full time around. Kind of play with that and see what I'm talking about. Right, so the reference edge keeps track of the larger increments as the slide moves along the track. These are your point 1. This case is the reference edge. You have to look at your specific dial caliper to see what is the reference edge for yours. Okay, here's an example of a gear tooth rack gear. It's used to change the linear motion, makes it slide. Very accurate dial caliper readings requires several steps. Before measuring, zero the caliper. So you're going to close the caliper completely. If it's not moving, See this little knob right here? Try unscrewing it a little bit because sometimes people will tighten those down and you can't get it to open. So kind of unscrew this knob right here first if it's not moving. All right, so then you're going to close it completely. Notice that this one is not on 0 after it has been closed completely. So this right here, this little screw, you're going to untighten it. With your hands, you're going to 0 it. You're going to move it so that it turns to 0. And then you're going to tighten this little screw again. So each time the pointer completes one rotation within the dial, the reference edge on the slider moves the distance of one blade scale increment, which is 0.1. Actually, it'd be 0.100 inches. Those are significant, which you cannot get on a regular ruler. You cannot get out to that number of significant figures. So one revolution of the pointer within the dial represents 1/10 of an inch. The dial is divided 100 times. Therefore, each graduation equals 1,000th of an inch, which is 0.001. All right, so determine the outside diameter of this pipe section. First, identify how many inches are being shown on the blade scale. So we look at the big numbers first. Notice it is after 1, so we know it's 1 inch. All right, reference edge is located between the 1 and 2. Now record inch significant digit. All right, so far we have 1.000 inch that we know positively. All right, so next it says identify the 0.1 inch increment marks shown to the right of the last inch mark. So notice that the one that we know for sure is the 4. So we know 1.4 to be sure now. Those are certain digits. So we can go ahead and add those together. Next, we look at the dial. What do we get from the dial? All right, so on the dial, I can look here, and it goes 10, 20, 30, and then I count, and here's the 5, 6, 7. So 0.037 inch mark is on there. So these are pretty much our certain digits. All right, if you look right at it, we're going to estimate. Notice it's right at the 7, but it's slightly over. So instead of adding that extra 0, we are going to add a 1 at the end. All right, so we know our certain digits for 1.437, and that uncertain digit then is the 1. Okay, add all the values together, 1.4371 inches. At the dial caliper interpretation practice, let's try this. All right, how wide is the block? Look at it for just a moment, see if you can figure it out. Okay, we know 1 for certain. We know the 4 for certain. At this point, we have not gotten into 10, 20, 30, so it's 02 that we know. Right? So you're not going to put a 2 here because that would indicate 20. So it'd be 02. So we know for certain right now 1.402. Now we're going to look a little closer, and that's a little over that line. If it was right on the line, we'd go ahead and put a 0 at it as our uncertain digit. But on this one, we're going to go ahead and say it's maybe a little over, maybe like 2. All right, so 1.4022 inches. All right, now I'm going to go ahead and open up your activity 3.4. I named it Dial Calipers. And then you're going to go ahead and complete that in your engineering notebook, and you are going to submit it here on Blackboard. I'll go ahead and do a practice video just so that way you can see me using one, and I will measure a couple of things with it.